Hello guys, welcome to Physics Grad. This is one of the lecture series in the maths playlist, and today we are going to study about Euler's theorem for homogeneous functions, which I intend to be using it to derive the conservation of energy in classical mechanics and may be useful in our other subjects as well. Alright, so let's begin. First, let's define what do we mean by a homogeneous function. Okay, so homogeneous function. What do we mean by a homogeneous function? So, a function f which depends on variables x1, x2 up to some xk is said to be homogeneous, is a homogeneous function of degree n if f of lambda x1 lambda x2 lambda xk, where lambda is some real number, is equal to lambda power n f of x1 x2 xk for all lambda greater than 0 and lambda xi belonging to domain of f. Okay, so this is the definition of a homogeneous function. So let's consider some example. Let's say f of xy is given by x square plus y square plus xy. Then f of lambda x lambda y will be lambda square x square plus lambda square y square plus lambda square xy, which is lambda square times x square plus y square plus xy, which is lambda square times f, right? So as you can see, this is a homogeneous function of degree 2. Let's consider another example which is not a homogeneous function. So that would have, let's say, the form x square plus y. Then f of lambda x lambda y will be equal to lambda square x plus lambda y, which cannot be expressed as some lambda power n times f of xy. So therefore f is not homogeneous. So with these two examples, it should be clear what is the meaning of a homogeneous function and what is the meaning of a non-homogeneous function. Okay. Alright, one more thing to consider. Let's say consider homogeneous function of two variables. Okay, then we have f of lambda x lambda y equal to lambda power n f of xy. So its degree is n, but it depends only on two variables. Okay, we can express this in another way as f of xy equal to x power n times some function g of y by x. So for example, if you consider fxy as before as x square plus y square plus xy, then this can also be written as x square times 1 plus y square by x square plus y by x, correct? So here g of y by x is y by x plus y square by x square plus 1. Okay, so that is the meaning of this. Alright, so with this much information, we are ready to state the Euler's theorem for homogeneous function. So what does this theorem say? So first I am going to state the theorem for two variables, and then we will prove it for two variables, and then I will write the theorem for the general case of, let's say, k variables. Alright, so for two variables, what Euler's theorem says is that if the function f is homogeneous, then x times the partial derivative of the function with respect to x plus y times the partial derivative of the function with respect to y should be equal to n times the function itself, where n is the degree of homogeneity. Okay, so here f is homogeneous, so this is true only for homogeneous function. So this is what Euler's theorem says in the case of two variables. So before we move on to the general case of some k variables, let us prove this first and understand why this is so. And then I am going to state the theorem for the general case of k variables, but we are not going to do the proof for that because it follows the similar lines which we are going to do for two variables, but only a more involved version of that. The algebra will be lengthy, that's all. Okay, so let us write the function f as x power n times g of y by x. Okay, so this is allowed by the definition of a homogeneous function. Then dou f by dou x would be simply n times x power n minus 1 g of y by x plus x power n into g dash of y by x into minus y by x square, right? Similarly, dou f by dou y would be x power n g dash of y by x into 1 by x. Okay, then if we evaluate this particular expression, what are we going to get? So by just substitution, we will get x times, so I am substituting these parts, n times x power n minus 1 g of y by x minus x power n g dash of y by x into y by x square plus y times x power n g dash of y by x into 1 by x, right? Alright, so let's expand this and see what we get. So this becomes n times x power n g of y by x minus, so here this x and x power 2, this will become x power 1 and this will become x power n minus 1. So x power n minus 1 g dash of y by a plus y by x times y plus, here again this x will become x power minus 1 plus y times x power n minus 1 g dash of y by x, and yeah, that's it. So if you compare these two terms, they are equal and of opposite sign, so they cancel out to 0, and what we are left with is n times x power n g of y by x. But this in turn is the definition of f, and therefore we have this is equal to nf, or we have proved x times dou f by dou x plus y times dou f by dou y is equal to n times f, which is nothing but our Euler's theorem. Okay, so we have proved it for the case of two variables. Okay, so now let us consider the general statement of the Euler's theorem. So in general, if f of x1, x2 xk is a homogeneous function of degree n, this implies what Euler's theorem says is that x1 times dou f by dou x1 plus x2 times dou f by dou x2 plus dot 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 plus xk times dou f by dou xk should be equal to n times f. Okay, so I'm not going to prove this statement because it follows the similar lines that we already saw for the case of two variables. Only difference will be, in this case we have to deal with some lengthy algebra. So if you understand how it is true for two variables, this also should be easy to understand. So let's consider an example. Let f be equal to, very simple case, x square plus y square plus z square. Then what Euler's theorem says is that x times dou f by dou x plus y times dou f by dou y plus z times dou f by dou z should be equal to 2 times the function itself, because the degree of this function will be 2 if you substitute for f of lambda x, lambda y, lambda z, then you will get lambda square times f. So this degree n equal to 2. So this should be equal to 2 times f. Let us just verify that. So this is equal to x times dou f by dou x is just 2x plus y times 2y plus z times 2z, which is 2 times x square plus y square plus z square, which is 2 times f. Alright. So in short, what we have proved is the following, or we have not proved this, we proved it for the special case of two variables, but in general what Euler's theorem says is that summation xi dou f by dou xi is equal to n times f if the function f is homogeneous of degree n. Okay, so that's the Euler's theorem. There are other forms of it also. For example, if you have again, if you consider two variables, then x square dou square f by dou x square plus 2 times xy dou square f by dou x dou y plus y square dou square f by dou y square will be equal to n times n minus 1 times f. And similarly for higher degree, if you see this, it is similar to the binomial expansion form, and you can, in fact, this is true for any such form, any higher powers also, but for the time we will not be using these results, but it is good to remember, and so I will not be proving this now. If it is needed, we can prove this in a future video. Alright, thank you for watching. See you next time.